Yeni Teknoloji ve Buluşlar konferansının yangın güvenliği ve cam başlığındaki son konuşmasını yapmak üzere Pilkington Teknik Danışman Sayın Christian Sart'ı sahneye davet ediyorum.
Thank you. Okay, thank you. So, good afternoon, everybody, and welcome also from my side. So, you know me by name already. I'm working for the technical department of fire protection glass, and yes, we are responsible for the worldwide market of this pretty special and high performance glass. And I just would like to give you a short introduction on that special glass within the next 30 minutes, 35 minutes. So you've almost reached the final, and I hope you are still able to lend me maybe at least one eye and one ear. Before starting with the agenda, let's have a look at this nice fire. I'm saying nice fire because sometimes fires help us to, of course, sell our product, but it also helps to make people a bit aware of what it means when we're talking about fire protection. So this is a fire which took place a couple of years ago in Spain, in Madrid. And you know that if you're designing such high-rise buildings, for example, usually you should consider fire departments or compartments and fire sections within the building to avoid, let's say, the spread of fire from one compartment to the other, to save the building, or at least to save part of the buildings in case of fire. We would like to give people the chance to escape from the building in case of such a horrible fire. And of course we would like to let the fire brigades give a chance to fight against the fire. And not only from outside, they also need to enter such a building to fight against the fire from inside and to rescue people from inside. And therefore there is definitely demand for products to protect against dangers of fires. And I know and I learned that the regulation in Turkey is not yet so strict, but I hope that maybe in the future we can work on this together, and you're the ones who can also work on this and have some influence on this. So let's have a short look to the agenda. First of all, I would like to give you now a short overview about the business unit of fire protection within the Pilkington NSG group. Afterwards, I will continue with the test conditions, the performance, the product range we have for fire protection issues, fire protection glass. And last but not least, I will show you some examples of applications and show you what is possible with fire protection glass and what maybe not. Okay, let's start with the short overview. Our headquarter is based in Gelsenkirchen in the western part of Germany. Maybe some of you know Schalke 04. This is a part of Gelsenkirchen. So this is also where I'm based and where I am working. We have the central stock manufacturing in Gelsenkirchen since 1978. So we have now more than 30 years of experience in the fire protection business. We were the one who improved the product step by step, and the product lines itself incorporating Pyrostop, Pyrodo and Pyroclear. So those are the three different kinds of products we have. I will talk about that more in detail a bit later, of course. We have several in-house test furnaces where we are doing product developments, product improvements. Two are in Germany, pretty big ones, and a smaller one is in the UK, so 3 test furnaces we are running. We have activities in all European countries, in North America, in Asia. We recently started in India as well. So we try to focus on the whole worldwide market with our glass, of course, as well. And Turkey is, of course, one of the countries now developing more and more also on the fire protection business. We are running more than 40 processing sites worldwide managed by Pilkington or by independent partners. That means we are producing our glass in Germany and Gelsenkirchen and selling them stock sizes 2 meter by 3 meter big to our processing partners. They can cut those and saw those stock sizes and then sell it to the end customer. So that means we have pretty short delivery time also in countries outside Germany. Okay, let's go ahead with the fire-resistant glass and why we're here. I brought a short video for you, 3 to 4 minutes, which shows how fast fire is spreading. In that case, it was a soccer game a couple of years ago in the UK, and maybe you can start the video. Maybe can you turn on the sound to have more emotions? So let's have a look at the time down there, and you will see that the fire will start in a couple of seconds. Something about against Galatasaray.
Sweeps a good ball out to Mark Ennis. Rickens the defender in front of him. Has gone out.
So you see that there are already some people moving over there.
Shipley. Well, we've actually got a fire in the stand on the far side of the ground.
So now there are the first flames over there. So please follow the flames as well as the time to see how fast it goes.
Now these are extraordinary scenes at Valley Parade. It's supposed to be a day of celebration. One hopes the stand doesn't burn down. And the game has obviously had to stop. I saw the smoke about a minute ago, but now that fire is beginning to rage. And the police are doing a tremendous job in getting people out of the stand and onto the pitch. But a day of triumph could turn into a day of disaster here for Bradford. These quite astonishing scenes, and I've just seen the police leading a couple of people out of the ground. And the smoke is now engulfing the pitch at one end. As that blaze grows, the stand has to be in jeopardy. Over a year ago, Bradford City lost their floodlights. They were blown over, and now the stand may well be burning down. And the 2,500 people in that
so
stand
it's just 1.5 minutes now.
are frantic to get out. And these are disastrous scenes for the club. One can feel the heat. And that is a catastrophic sight for Bradford City Football Club. The whole stand is going up in flames, and that person there looks to be burning. And the timbers are coming down onto the ground, and this is horrific. There is no cause for celebration for anybody here. This is awful. They came to celebrate the club's promotion, and I can feel the heat. It's almost beginning to burn me over here, quite honestly. The whole stand is going to have gone in the space of a few minutes.
So it's 2 minutes now, maybe 2.5.
Quite extraordinary scenes at Valley Parade. This was supposed to be a day of utter joy, triumph and celebration. It's turning it into a nightmare. There's a policeman on fire there. He's managed to quell that. A woman being led from the stand, and there are still 1 or 2 people, and I must say it is only 1 or 2 isolated people in there. But the roof is caving in. The smoke, the black pall of smoke is rising hundreds of feet in the air, and the whole place is scorching. having a new ground at Valley Parade. They might soon have to have one, because this is the day that Valley Parade Football Club, the football ground, is burning down.
This is how it looks after 4 minutes. Pretty impressive, I think, to see how fast such a fire is spreading. In that case, through a football stadium or through a soccer stadium. So how can we guarantee that if something like that happens, people working in an office, working in a hospital, working in a shopping mall, whatever, are able to escape from such a fire? When we're talking about fire protection glass, we need to be aware that it's not only the glass itself which helps us to protect the people. It always needs to be considered that it is a framing system which needs to be proved and tested, and only if we use a framing construction with all fixing details designed for fire protection together with the surrounding construction and fixed properly to the surrounding construction. By the end, of course, the fire protection glass itself. Only if we consider all these components, then we achieve a proper solution for fire protection issues. So we have, for example, a door over there for the N90 to see that it's not only the glass, of course, the frame itself needs to be designed for fire protection itself. But of course, we are only selling the glass. Our customers are frame manufacturers, so I will focus now, of course, only on the glass, not on the frame itself, but you need to be aware of that if you're designing something. So let's come to the requirements for fire-resistant glass. We distinguish 3 different classifications. First of all, we're talking about the so-called E-class. It means that it fulfills just basic integrity. So there's still heat passing the pane, but it's a barrier against smoke, flames and fumes. So this is, in our case, in our product range, the Pilkington Pyroclear. Then there is the next classification called EW. It's a classification with a higher performance, with the so-called enhanced integrity. So we have the basic integrity plus reduced heat radiation. The second level with the highest performance is the glass which fulfills total thermal insulation. So we have the basic integrity plus a full thermal insulation. That means if somebody, for example, is escaping in front of a glazed partition, then he will not influenced by the fire. He can even touch the surface because there is no heat passing the pane, and no heat influencing the people passing a glazed partition or a door or whatever. But why do we actually need fire protection glass? Why does glass break in case of fire? You know that annealed glass is a non-inflammable product, but there is a more or less simple physical background. So imagine that you have a glass installed in a frame, and that glass is going to be heated up. Then you have 2 different parts. One part in the middle, part A, will be, of course, much shorter than part B, covered by the frame. So you have different temperatures in case of a fire. A hot temperature in the middle and a much colder temperature at the area B, covered by the frame. So the middle, the hot area, is trying to expand. The cold area is resisting this expansion. And this different behavior of the hot area compared to the cold area causes tensile stresses. So we're saying that if there is a temperature difference from here to here of approximately 40 degrees, so that means you have 20 degrees here, 60 degrees in here, then normal annealed glass will get some cracks and then totally collapse in case of fire. So although it is a non-inflammable product, annealed glass is not able to withstand any fire. So no fire resistance performance for normal annealed glass. That is the reason why we produce fire protection glass. And we need it. So let's come to the composition of fire-resistant glass. The composition is in general the same for the Pyrostop and the Pyrodur glass. So for the glass with total thermal insulation and for the glass with the sun-reduced heat radiation. What we do is we use simple float glass. I just explained to you, float glass will break in case of fire, but we want the float glass to break. Because what we do is, we take the float glass and we fill some intumescent interlayer on that float glass. This intumescent interlayer is not visible, only if it reacts in case of fire. So what we do is, we take several panes of float glass with several interlayers in between those float sheets. And we put together a kind of sandwich. So several float glasses with several interlayers foaming up in case of fire. So this is the basic construction of a Pyrostop and a Pyrodur glass. What else is possible? Of course, you can build up double glass units for additional sound control requirements or solar control requirements, whatever. So all you know from the non-fire protection glasses, more or less also possible with fire protection glass. We distinguish internal applications and external facade applications. The composition actually is the same. There is only a minor but a very important difference. We include a laminated glass into that composition to protect our interlayers from UV radiation. So if we have fire protection glass installed in a facade and if it is exposed to sunlight, for example, then we need to protect the interlayers from the UV radiation. And therefore, we incorporate a PVB layer which absorbs the UV radiation. Again, double glass units, of course, possible. Externally and facade application, of course, usual. So again, some picture to see again the composition. You can see the different float panes with the interlayers, additional PVB layer for external products, and this is the typical composition of Pyrostop and Pyrodur. So let's have a look at the reaction in case of fire. So this is again how it looks like: float glass interlayer, float glass interlayer. The fire starts. We have temperatures of 100, 200, 300, 400, up to 1000 degrees in case of fire. The first float glass cracks. The first interlayer is foaming up and is building a kind of opaque shield. I will show it to you on the next slide. I have some pictures as well of that. And what happens is that in this interlayer, which is foaming up, there is some water included. And this water is vaporizing. And so the whole construction and the whole glass is cooled down to a certain level. So for such insulated products, we measure temperatures on the unexposed side, on this side, after 30 minutes, after 60 minutes, after 90 minutes, whatever we would like to achieve. And the surface temperatures we are measuring on this side are after the required time about 100 to 120 degrees. On this side we have almost 1000 degrees. So there's really a huge difference if you're using an insulated product like that one. So the interlayers are foaming up step by step after 30, 60, 90 minutes, whatever we need. All interlayers performed. And in a standard fire test, it might look like that. We have in that case a steel frame installed in a 4 meter by 4 meter big furnace. The burners are starting, and you can still see after 1 minute the back of the furnace. But what you can already see is that here is the hottest point in the furnace, and the first interlayer has already starting to react. So after a couple of minutes it looks like that. All interlayers, all first interlayers in the composition have started to react due to the heat we have in the furnace. So the reaction starts at 100 degree. 100 degree and such a fire test are achieved after 1 minute, and then it goes straight up until 900 and 1000 degree. So if all interlayers have reacted, it looks like that. You won't see the furnace and the fire behind it anymore, but it's possible to stay in front of the pane, to even touch the surface, so you are totally protected by such insulating units. Okay, there is another composition. I told you at the beginning that there is also a so-called E-class that is just for basic integrity. We offer such product for 30 minutes and for 60 minutes requirements, and it's really just monolithic glass, specially toughened, especially the edge working is a special one, specially grinded, and with such very thin, very light, and actually pretty cheap product. We can achieve basic integrity for 30 and for 60 minutes. So in a fire test, for example, it looks like that after 35 minutes. Huge pane, in that case 1.8 by 3.5 meter. The glass is still in place, but you have all the heat radiation passing the pane. So there are no interlayers, nothing which reacts, it's just the pane itself which stays for the required time due to the way how we produce it. So for E60, for example, typical application at the moment in Turkey, as I learned. So pretty big partition, steel frame in that case, burners are starting, and after 66 minutes everything is still, let's say, in good shape. Although the deflection of the frame is of course very high, but all paints are still okay. And now I was talking about heat radiation and insulation. It's a bit difficult to feel it when I'm just explaining it. So I have a very simple picture, but it explains it in a very simple way. On the left side there is a pyrostop installed, so with intermittent interlayers absorbing the energy from the fire. On the right side there is a pyroclear installed without any interlayers, and you see the difference, very simple. On the left hand side you can even touch the surface. On the right hand side, if you put some paper, for example, in front of the pane, it will easily ignite. So that is the huge difference between insulated glass and non-insulated glass. Okay, let's summarize the product range we can offer. Looking to pyrostop for insulation and integrity. Multi-layer intermittent glass comprising float glass. Full thermal insulation means basic integrity plus thermal insulation. Available for 30 minutes, 45 minutes, 60 minutes, 90 minutes, 120 minutes, up to 180 minutes. So just to give you some impression, the 30 minutes type is 50 millimeter thick. Its weight is about 30-35 kilo per square meter, and the type for 3 hours is 94 millimeter thick, with a weight of almost 200 kilogram per square meter. So you see, as higher the requirement is, as thicker the glass will be, as more interlayers are inside, as more interlayers we need to react, but it's possible to achieve even 3 hours fire protection with such a huge and big and thick glass. Okay, the Pyrodur EW class, probably not so important for you in Turkey. Again, the glass comprising float glass. integrity plus reduced radiation for 30 and 60 minutes classifications available. So far we actually only have one country where this class is implemented in the building regulations. It is the Netherlands. So this is probably not so important for you. So for you it's, I would say, mainly the Pyro-Stop as well as the Pyro-Clear. Modified toughened clear glass with a round shaped edge, just for basic integrity, available at the moment for 30 and 60 minutes. I heard that 90 minutes are more and more, let's say, the demand is getting higher and higher for E90 in Turkey, but please keep in mind a bit the differences between insulation and a non-insulated glass. So if you install a glass for 90 minutes, the heat radiation passing the pane is of course pretty high. So everybody who needs to run in front or to escape in front of such a glass is of course could be hurt. Okay. Further requirements. We heard that already from Chris and from Wolfgang. Fire protection is pretty often only one matter. We always need to fulfill requirements besides the fire protection. So what can we do, or what is possible? Safety performance. I mean, what happens if somebody runs against the pane? Will it break in a safe way, or will it break in an unsafe way? So it will break in a safe way, so it's comparable to a laminated glass with a PVB layer. So the safety performance regarding the breakage behavior is safe. Security glazing, burglar resistance, that is also possible for prisons, for example, something like that. Solar control and thermal insulation with low E coatings and a double glass unit to improve the U value or the G value. We heard about that today already a couple of times. Sound insulation with an additional outer pane, incorporating a special sound control PVB layer. That is also no problem. Mechanical resistance, so the glass can of course withstand wind loads, snow loads, whatever you know from typical applications in the non-fire protection area is also possible for fire protection glass. Long-term stability. I told you that we started with a business more than 30 years ago, so we had the chance to take some paints from a building which were installed for more than 20 years, and we took those paints due to renovation of the building. We took those paints out and tested them internally and officially, and it was proved that the behavior after 20 years was still the same as we would have produced it today. So the requirements also of glass installed for more than 20 years is still perfectly given. Transparency and quality. I would say that you won't really see if a fire protection glass is installed or not due to that high transparency we can see. So you can have a look at the glazed door. There's I guess it's 990mm type, so it's 37mm thick. You can see if you will see any difference compared to a normal 6mm or 8mm glass regarding the appearance and the light transmittance. So just go around after my presentation and have a look at the door to see what is possible. Okay, all those requirements are possible with fire protection glass. And I promised to show you some examples of applications. So I put some pictures together. Some of you know maybe sometimes fire-resistant doors and escape routes with small vision panels only. Of course, this can be substituted by fully glazed doors. Same for the surrounding construction. For the wall, it could be a brick wall or a concrete wall. But of course, with a fully glazed partition, it's actually much better. Same for an emergency staircase, for example. You won't see it because it's still a brick wall, but if you remove it and put some glazed partition inside, you have such partition in that case for EI90, so 90 minutes interrogation insulation, to let the people escape over the escape route for a time of 90 minutes. Natural light through light walls. No need that I'm losing too many words on that. I think you can see what is possible. Escape routes on the left side to, in that case, to divide fire compartments and to divide long emergency routes into different compartments. So you can use fire doors to divide such sections. Various shapes are possible with fire protection glass as well. This is the project in Japan, the library in Sendai. This is again a glass for 60 minutes interrogation insulation to protect the staircase. This is one typical application for an external requirement, so you have just a small area of the facade glazed with fire protection glass to avoid the spread of fire from one part to the other part through the facade. So this is actually a typical application for facades. Typical office building, very long escape route, 30 meter long, 35 meter long, and people who needs to escape in here in case there is any fire on the left or on the right side. This can be glazed with, fully glazed with fire protection glass as well. And one project we did in Moscow, EI13, with a huge facade construction. VW plant in Germany to protect that area and to avoid the spread of fire from one level to the next for 90 minutes. Again, the library in Sendai, I've already showed you, this is a good example for pyroclear. That means for 60 minutes integrity, the project without fire-resistant glass and with fire protection glass. So all this is pyroclear for 60 minutes integrity to save the structure, the steel structure, and to avoid that flames are passing from one level of the building to the next. Again, pyroclear for E30 projects glazed indoors, internally for a lower safety level, but this is of course possible as well. Okay, almost finished. So to summarize my short presentation, fire-resistant glass can be used in a wide variety of building applications. I just showed you just a few of them. Make sure that the glass is always a part of an appropriate fire-resistant, fully tested framing system. That is what I mentioned at the beginning, so it's not just the glass. You need to also consider the framing construction. We have a wide choice of fire-resistant glass types with different levels of performance, with different safety levels, 3 different safety levels. Actually, so the first one is the one for integrity and insulation with pyrostop glass. Second one for the integrity and reduced heat radiation. This is pyrodur, and at the end the pyroclear for integrity only available for 30 and 60 minutes at the moment. Further requirements, as I mentioned, as solar control, zone insulation and so on, available as well. So thank you for your attention. That is what I brought with me. Thank you.
Small question. Did you withdraw the wire glass from the scope of fire rating?
Sorry?
Did you withdraw wire glass from the scope of fire rating?
Wired glass is still available through the UK. So there's a PyroShield 2, called issue 2. I think it's also included in the glass handbook. It's available through the UK, as it is not part of our business unit in Gelsenkirchen because we are not producing it in Gelsenkirchen, Germany. I'm not talking about that today, but it's still available through the UK.
Thanks. What about the performance of glass for earthquakes?
For earthquakes?
And do you need to use a special glass? And what happened in Sendai with that 9 Richter?
Okay, so with earthquakes we have actually, so far as I know, no experience. So at the end it's a question of the frame construction itself to glaze the glass in a way that will not collapse. But we have, so far as I know, never received any requirements for earthquake, but if there is a project we can think about that, of course. Regarding solar control, you mean regarding the heat penetrating, the heat from the sun penetrating the glass? What's the second question?
In Sendai, what happened?
Inside? In Sendai?
Yes.
What happened? Good question. Good question. I don't know. I don't know. I have no information so far what happened there. No news, no bad news, hopefully. Yes, hopefully. Hopefully.
Maybe, I think she has another question, but we are almost finished, so she can get back to you later with the scarf.
Okay, you can back to me later on, if you want.
Evet, değerli misafirlerimiz, Float Glass düz cam üretim teknolojisinin yaratıcısı Pilkington'ın düzenlemiş olduğu Yapısal Camlarda Yeni Teknoloji ve Buluşlar konferansına katılımlarınızdan ötürü çok teşekkür ediyoruz. Konferans izlenimlerini yapı.com.tr adresimizden de takip edebilirsiniz. Hepinize iyi akşamlar diliyorum. Teşekkürler.